Good morning, my lovely kiddos and my future mathematicians. Today we are starting Chapter 7 with our Section 7.1a. We are going to be reintroduced into polygons. Now, we have covered polygons a little bit before, but now is when we are going to dive deeper into them. Okay, so our first thing is that there are 3 rules that we need to have a polygon. Okay? These rules that every polygon must meet is that it must be a closed figure. Okay, so what I mean by that is it can't look like an angle. It has to meet at all sides. It has to be closed. Okay, rule number 2, it has to be made only with straight lines. So if there's any kind of curvature in our figure, even though this is closed, since we have a curved line here, this is not a polygon. A polygon must be made of only straight lines. And our third and final rule here is they have to be 2-dimensional shapes. So we can't have a cube, no matter how cool it looks, because it is not a polygon. Okay, it has to just be a flat figure. Okay, so all polygons must meet these 3 rules. If they do not meet all 3 of these rules, then we do not have a polygon. Okay, let's review the names for our polygons based on the number of sides that they have. Okay, this is called the classification. Okay, so if a polygon has 3 sides, then we call that a triangle. If a polygon has 4 sides, we call that a quadrilateral. If a polygon has 5 sides, it is called a pentagon. If a polygon has 6 sides, it is called a hexagon. If a polygon has 7 sides, it is a heptagon. If a polygon has 8 sides, it's called an octagon. If a polygon has 9 sides, it is called a nonagon. And if a polygon has 10 sides, then it is called a decagon. Now, if a polygon has more than 10 sides, we refer to that as an n-gon. Okay, so if we have 12 sides, this would be a 12-gon. We also have to go over the definitions of convex and concave shapes. Okay, so let's do concave first. A concave shape is a shape that caves in on itself. So I'll draw an example here. So looking, we have 1, 2, 3, 4, 5, 6. Let me draw the numbers here. 2, 3, 4, 5, and 6 sides. So this would be a hexagon. And we know that it is a concave hexagon because if we follow all of the lines on our hexagon, we can see that some of them go through the interior of our figure. Whenever we have sides that go through the interior of our figure here, like sides 4 and 5 do, we know that that shape is caving in on itself. So it is a concave shape. Now, convex shapes are shapes that do not go through the interior. So drawing here, we have 1, 2, 3, 4, 5, 6 sides. So this is another hexagon. And if we follow all sides of our hexagon shape, we can see that none of them go through the interior of the shape. Since none of them go through the interior of a shape here, we know that this is a convex shape. Going through a couple more definitions here. We also have words to help us classify our polygons later in the worksheet. We have the word equilateral. And we have used equilateral when referring to triangles. However, equilateral has a much broader definition of a polygon where all sides are congruent. Okay, so let me write that out. Any polygon that has all sides, and that's so important, I'm going to underline it, congruent. So let me draw an example for you guys here. I'll draw another hexagon because apparently that is my favorite polygon today. And we know it is a hexagon because, again, it has 1, 2, 3, 4, 5, 6 sides. And although my drawing doesn't look it, an equilateral polygon is where all of the sides are congruent to each other. Our next definition is equiangular. And again, we talked about this with triangles, but it has a more broad definition. And this is any polygon where all angles, and again, so important, I'm going to underline, are congruent. This time I'm going to draw a quadrilateral with 4 sides so I don't bore you guys with these hexagons. So here's our quadrilateral. Again, we know we have 1, 2, 3, 4 sides. Okay, and then any equiangular polygon just has congruent angles. Okay, I put right angles because this is a square. However, with any shape, I'll go back to my hexagon here, where all the angles would be congruent to each other. Our final definition before we get into classifying some polygons is a regular polygon. Okay, a regular polygon is a polygon that is convex, meaning it does not cave in on itself. It is equilateral, meaning all the sides are the same. And it is equiangular. Okay, meaning all the angles are the same. So let's go ahead and draw one of those. Okay, so here we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. Okay, we can see that it is convex. It does not, none of the sides go through our interior here. And if we draw our tick marks once on each side, showing that all of the sides are congruent, then it is equilateral, and it would also have to be equiangular. So all of our angles would have to be congruent as well. So since this is convex, it does not go through the interior. It is equilateral, all of the sides are congruent, and it is equiangular because all of the angles are congruent. This is a regular polygon. Okay, so let's jump into some examples. Our first example is a shape that looks like this. Okay, so remembering back to our 3 rules to make a polygon, this shape is closed. There is no open parts of it, so it is closed. It is made with only straight lines, and it is a 2-dimensional shape. So this is, in fact, a polygon. So we want to classify this polygon. First question is this concave or convex? Is this shape caving in on itself, or is it not? Okay, if we follow one of the sides here, we can see that we go through the interior twice right here. So this is 100% concave. It is caving in on itself. The next thing is how many sides does it have so that we can classify that. We have 1, 2, 3, 4, and 5 sides to this. So this is a pentagon. And it is neither equilateral, equiangular, or regular. Okay, so I'm going to write neither. And this is in your directions for the homework that it's asked you, is this equilateral, equiangular, regular, or neither? Okay, so this would be neither. For number 2, we have a polygon that looks like this. We have some tick marks. We have some strikes. So first thing is this concave or convex? Do we have any sides that go through the interior of the polygon? And no, we do not. If we follow all of our sides, we can see that none of them go through the interior of our shape here. So this is convex. Okay, second would be to classify it based on the number of sides. So counting our sides, we have 1, 2, 3, 4 sides. So this is a quadrilateral. Getting kind of squeezed over there. And then is this equilateral, equiangular, regular, or neither? So we can see that this is an equilateral polygon because all of the sides are congruent to each other. So this is definitely equilateral. And although all of our angles have strike marks, they are not all congruent to each other. One strike does not equal 2 strikes. So these are 2 different angle measures. So this is not equiangular, and it cannot be regular either since it is not equiangular. So these are the 3 classifications that we have. For number 3, we have a shape like this. Okay, we have some tick marks. All right. So first thing is this a concave or convex shape? Is this caving in on itself or is it not? Does it go through the interior or does it not? If we follow these 2 pieces here, we can see that they continue on into the interior. So this is definitely concave. Next, we have to count the number of sides and then figure out what that classification is. So we have 1, 2, 3, 4, 5 sides. So this is a pentagon. And then we can see that each of the 5 sides has a tick mark, which means it is an equilateral shape. Okay. Number 4. And then we have some tick marks and some strikes. Okay, so first things first is this a convex or concave shape? So do our lines or our sides go through the interior of the shape? If we follow all of our lines, we can see that none of them go through the interior of the shape. So this is a convex polygon. Next, we have to count the number of sides. We have 1, 2, 3, 4, 5, 6 sides. So this is my favorite of the day. That is a hexagon. Okay, and then we have strikes on every single angle. So we know that this is an equiangular polygon. And although we have we have tick marks on each side, we have single tick marks on our two sides, on each side. And then we have two tick marks on the top and bottom. Again, one tick mark does not equal the length of two tick marks. Okay, so since those are not congruent, one is not equal to two, all of our sides are not congruent to each other. So this is not an equilateral polygon. Since it's not equilateral, it cannot be regular either. Okay, number 5. Let me try that again. Okay. So here, let's go ahead and count. All right, let's look at all of our sides. The first thing we want to do here, oh, I'm sorry, I forgot my ticks and my strikes. Okay. So first things first is I want to look at the sides here, and I want to see if any of them go through the interior of the shape. Looking at all of our sides, we do not have any sides that go through the interior of our shape. So this is a convex shape. Next, I want to count the number of sides that we have and classify that. So we have 1, 2, 3, 4, 5, 6, 7, 8 sides. So this is an octagon. And then looking here, we have tick marks on each side, meaning that all of the sides are congruent to each other. So that would mean it is an equilateral. And all of our angles have one strike mark on it, meaning it is equiangular. But remember, by definition, if a shape is convex, if it is equilateral and equiangular, we can say that it is regular. All right, last example here, kiddos. All right. So we are given this quadrilateral, the shape with 4 sides, and we are told that it is a regular polygon here, meaning that it is equilateral, all the sides are congruent, and it is equiangular, meaning all the angles are congruent as well. Now we are given that this bottom side here is 15 units long, and that the side on the right side is a x plus 9 units long. So since we know that this is regular, we know that all the sides are congruent, so we can set the yucky algebra piece of x plus 9 equal to 15, and then solve it like an algebra 1 equation. Subtract 9, plus 9 minus 9, those cancel because they go to 1, leaving us with a positive 1x. We don't have to write the 1 for, and 15 minus 9 is 6.